of a state-of-the-art 0.3 million tons per annum bar and section mill. Let's begin with the configuration of this mill. As you can see, this is a fully continuous mill to produce rebars, flats and angles. The raw material used here is continuous cast billet of 150 mm square and 12 meters long, weighing about 2 tons. The finished products are TMT bars from 8 mm to 40 mm, flats up to 100 by 20 mm and equal angle from 50 mm to 90 mm. During TMT bar rolling, the mill uses slitting technology to achieve its rated capacity. However, Kathuria is able to execute projects up to 500,000 tons of capacity. Additionally, it is also active in mills with low capacity such as 100,000 tons with semi-continuous and cross-country configuration, depending upon the customer's requirement. There can be a combination mill with multiple products called as merchant mill. Kathuria has successfully supplied, erected and commissioned various such mills across the globe. Let's move on to one end of the mill, starting with reheating furnace. The cold billets are put on the Paul beam charging grate to be fed into the furnace. This one is a walking hearth furnace fueled by natural gas. The heated billets are discharged through the exit gate with the help of a roller table and fed into the mill stand for rolling. The roughing mill comprises 6 housing less mill stands in horizontal, vertical configuration numbered as C1 to C6. After the billet and rolling passes through the roughing mill, its front and tail ends are cropped by crop and cobble shear called CCS1. It is located between stand numbers C6 and C7 and is also used to chop the cobbles into multiple lengths so that the mill downtime is minimized, as time is money and it is wise enough that each and every minute is saved. I'm sure you will all agree to it. We now move on to the next section, intermediate mill. It again comprises 6 housing-less mill stands arranged in horizontal vertical configuration numbered as C7 to C12, followed by another crop and cobble shear called CCS2. This shear has the same functions as CCS1. The crop ends are collected in a bucket placed in a pit next to it. Now, right beneath us is the main pulpit room, which can also be referred to as central command room of the entire operations in the mill. We have now reached the finishing mill train, which has 6 housing-less stands with C13, C15 and C17 stands in horizontal position, C14 stand in vertical position and C16 and C18 stands in convertible position. The slitting takes place at stand number C16. The convertible stands are kept in horizontal position during slit rolling and in vertical position during single strand rolling. A quick stand changing mechanism is provided in finishing mill area to ensure that rolling hours are maximized, as time is money. Post the rolling comes the quenching process. Here the bars are treated thermomechanically to attain the desired strength and properties by passing through high pressure water. The quenched bars, after being cut through a dividing shear, are then transported to one of the most significant parts of the mill, the cooling bed. It holds the key to reach the desired capacity of any rolling mill. This cooling bed is suitably designed to cater to the production cycle of bars and section from the mill. The cool bars are then cut to commercial length with the help of a 350-ton cold bar shear installed at the exit of the cooling bed. While the bars are being transferred through bar transfer system, the short bars are fished out by short bar collection system. This layer is then passed through an automatic bundle tying machine, which does multiple tying to form a master bundle of desired weight. The tied bundles are moved by overhead crane and stored in finished goods area.